And hello again, my little mathematicians. If you could please follow along on E26, which is page 23 in your packet. Again, that's E26, page 23 in your packet. That would be fantastic. I really like this page because it kind of summarizes the main three graphs that we cover in Mod 16 for the statistics unit. And more importantly, it helps us see, why do we even have so many different ways to describe data? Why do I need three different types of graphs? Why can't I just use one? Okay, so let's take a look at this one particular data set right here, and I'm going to represent it in all the three different types of graphs that we've discussed. So the first one is, let's do it in a dot plot. So when you do it in a dot plot, you look at your smallest number, which is 70, and your biggest number, which is 98. And you're going to draw a number line. Since it goes all the way from 70 to 98, I probably would like to count by twos on my number line. Okay, once you have your number line drawn, you're going to start putting your data values above each number, however many times it's represented. And please cross them off as you go, so that way you can keep track. So 80, we're going to draw a dot above 80. 72, draw a dot at 72. Notice how the dots are the same size and they're in line with each other, so that way you can easily see how many more times certain numbers occur. Okay, 82, draw a dot above 82. 80, there's 1, 2, 3 more of those. So draw 3 more dots above 80 and cross those off. And then there's 2, 88, so draw 2 more dots at 88. 84, cross off, draw a dot. 92, cross those off and draw 3 dots at 92. And then 96, cross off and draw a dot. 70, cross off and draw a dot. 90, cross off and draw a dot. 98, cross off, draw a dot. 92, cross off and do another dot at 92. 88, cross off, do another dot. 92, cross off, another dot. 90, cross off and do another dot at 90. 80, cross off, do another dot at 80. And finally, cross off 84 and draw a second dot at 84. All right, I like to always double check how many numbers were in my data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and count how many dots I drew. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. Make sure that those numbers match. They did. Huzzah, we're done. Okay, there is my pretty little dot plot. Now, this is talking about scores in a math class. So when you have 70s, that's like a C, 80s is a B, and 90s is an A. So from 70 to 79, how many dots were there? There were 2. So 2 C's. From 80 to 89, how many were there? Count the number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 B's. And finally, for the A's, 1, 2, 3, 4, 5, 6, 7, 8, 9 A's. Now, I did this to help me with my histogram, because there's my different ranges that would be good to break it up between. So when I go ahead and draw my histogram, I'm going to have along the bottom my math scores from 70 to 79, 80 to 89, and 90 to 100. Okay, and then I'm going to describe how many times they happened. Well, I need to go all the way from 2 to 11, so obviously I can't count by ones. Let's count by twos. Okay, so for the 70 to 79 range, the C's, they happened only twice, so go up to the 2 mark. For the 80 to 89, there was 11 of them, so I'm going to go between the 10 and the 12. I'm going to draw halfway there to the 11. And then for the 90 to 100, there was 9 A's, so I'm going to go between the 8 and the 10 at the 9 and shade up to there. Now this is a histogram representing the math scores. Finally, to do a box plot, or what's referred to as a box and whisker plot, you list them all in order from least to greatest, so 70, 72, 80, 80, 80, 80, 80, and so forth. Okay, list them all out, all the way up to the 98 score. And you need to find the median of those. But first off, okay, I'm going to just kind of like I drew my dot plot, I'm going to draw a number line all the way from 70 to 98. So let's have a number line that looks the same. And I'm going to graph my minimum value at 70. And I'm going to draw my maximum value, a dot at 98. Then I need to find my median. So I'm going to cross off from least to greatest. Okay, so from the beginning and the end, beginning, 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 end, beginning and end, beginning and end, beginning and end. It's between this 88 and 88 right here, which what's between that? 88. So my median value is 88. So I'm going to draw a dot at 88. Now I also need to find my lower quartile, which is the bottom, the median of the bottom half, because the median splits your data set in half. So here's the bottom half and here's the upper half. To find the lower quartile, find the median of the bottom half. So cross off from the 70 and the 88, the 72 and the 84, and so forth. So beginning and end, beginning and end, beginning and end, beginning and end, beginning and end. Okay, which puts me right here at the 80 is my median of the lower half, otherwise known as my lower quartile. Okay, so I'm going to draw a dot at the 80. Now to find the median of my upper half, I'm going to cross off beginning, end, beginning, end, beginning, end from the upper half. Okay, so beginning, end, beginning, end, beginning, end, beginning, end, and so forth. We get to the upper quartile, or the median of the upper half, which is 92. So I'm going to draw a dot at 92. Now I connect the minimum and the lower quartile with a whisker, and then I draw a whisker from the maximum to the upper quartile, and then I draw a box around my median, and then I draw a line down from my median. And this is called a box and whisker plot. The two lines at the beginning and end are called the whiskers, and there's my box. Now, what a box and whisker plot does is you have the lower 50% and the upper 50%. So right here, let's focus on the lower 50%. You found the median of it, so you divided it in half. What's half of 50%? 25%. So that means this is 25% of the data, this is 25% of the data, this is 25% of the data, and this is 25% of the data. So at a quick glance, you could see the upper 25%, the lower 25%, and then the middle 25 and 25, so middle 50%. All right, and that'll come into play later, you'll see. Okay, because if we continue on, it asks, here's your dot plot, your box and whisker plot, and your histogram. It says, which graph is best for finding the most common test score? So the actual test score, this doesn't tell me an individual score. Neither does this one. This one does. So I can see the individual scores and what the most common was by looking at the peaks. Oh, the most common score was 92 or 80. That's what most people scored. So a dot plot is the most helpful because I could just look at the specific peaks, and that tells me which ones happen most often. Okay. If they said, explain which graph is best if you want to know how many students scored a B, well, which one do you think makes that the easiest to see? Yeah, I could use this and be like 70 to 80. So right here, two of them. And then from here to here, okay, let's count how many that is. And from here to here, how many's in here? Oh, the most for the B. That's a lot of work versus I could just look right here and be like, oh, this is the highest. And that's 88 B's right here. This one happened the most, B's. Okay, so the histogram is the most helpful if we're looking at a specific range. It says, what if you were asked to explain which graph is best for a teacher who wants to know the range of scores for the bottom 25%, the middle 50%, and the top 25%? Well, Well, from the last page, you guys could see that that was when we were talking about the box and whisker plot, because this whisker is representing the bottom 25. This whisker is representing the top 25. And then you have 25, 25, or middle 50. So the middle 50, the upper 25, and the bottom 25% of the class. So the box and whisker plot is the best to represent that. Why is it important to display data in different ways? Because depending upon what type of question you're asked and what you're asked to analyze depends upon what type of graph you want to create to analyze that data. So again, what are they asking you depends upon which type of graph you want to create. So then at a glance, you can quickly answer that specific question. And that's why we don't just give you one type of graph. We want you to know how to use all the different types of graphs so that no matter how you're asked to analyze the data, you can do it really quickly. All right. So congratulations, guys. You now have covered the 3 different types of graphs that we do in statistics. Good job.